Hi everyone, welcome to Introducing the Open Source Semantic Graph Editor of Deutsche Bahn. This session will be presented by Jörg Baach. Over to you, Jörg.
Thanks a lot, Dania. Let me quickly share my screen. I hope that you can see it. I'm very pleased to be here. And I've already listened to fantastic talks, especially by Tony and Pierre just a short time before. And we are here to introduce the open source semantic graph editor of Deutsche Bahn. What does that mean? First, who are we? Deutsche Bahn is one of the largest mobility and logistics companies. We basically run the train system in Germany. And within that DB group, you have the DB sister, which is the driver of digitalization. Basically, we are the IT department. And within DB sister, you have our team. And we are an innovation team with 10 members, and we work on data reconciliation. We bring data from different sources together, find data quality issues, and integrate data. And in order to do that, we have a unique approach. And that approach works on top of graph databases, and we use ontologies being networks of meaning, of metadata describing that data. And we need all that to do our work. And in order to do what we do and also help our customers inspect their data, we needed some things. We needed an editor for graph databases with semantic support. We needed something that works with large labeled property graphs. We also had some other needs like the persistent arrangement of nodes and the other things that you find here. And I'll explain in a minute or two what that actually means when I do a live demo of the things. There are also not only the things that we need, but also things that we want. You can find them here. And I really want to highlight the first point, set-based browsing. There is this video by David, which he published, I think, around 17 years ago, and it's still eye-opening. I really would recommend watching that video. The other things that we have here are, well, they'll become obvious in some minutes as well when I show you what we've done. One can ask, why didn't we just use one of the existing tools? And within the world of labeled property graphs, we didn't find anything that really matched our requirements, especially not open source tools. But from what we've seen, really to the best of our knowledge, it's also in the closed source world that we didn't find what we needed. And we were thinking and researching whether we could switch worlds, going from LPG to RDF. But we found RDF to be limited in at least two ways. First, as I said, we work on large graphs, and we need to do analytics on those large graphs. And for that, we need graph algorithms and libraries that support us there. And we just couldn't find anything for the RDF world, which would work on the whole of the graph in a sufficient way. The other thing is, in the way we model, we have lots of data on the relationships, and only RDF star really supports that. Pierre pointed that out in his talk a short while ago. So for us, that meant basically we had to do it ourselves. And what we did was an in-house development of the graph editor, and the graph editor has been open sourced in August of this year, so just some months ago. And you'll find it on GitHub at that address that you see right now. We've basically done the opposite of what Tony said for GraphAware. So we didn't implement our own display routine. Instead of that, we used existing open source tools. We used Python and Flask for the back end, used React and Sigma.js for the front end. And I think by that, we more or less got everything we needed and wanted. And I'll show you what we've achieved, but please keep in mind, this is still in the early stages. Things will not work, and we will encounter bugs during the next 20 minutes of the presentation. So please be patient and have fun. Now, before I dive into the editor, let me quickly show you one picture. And this is the world that we represent in our database. You have a small island, you have two mountains on the side, and you have a train system on that island. So basically, here's the train station, and you find some switches in front of the train stations, and there are nice signals. And obviously, or well, it's hidden, but I guess everybody assumes that the train is going uphill here, crosses the bridge, and goes downhill in circles before it comes to the train station again. We can also have a look inside. Here you see what's really happening. This is just an illustration contributed by one of our team members. So we've put data describing that little island into the database. And now let's have a look at the graph editor. This is what you see when you connect to it. You need to enter your credentials for the database server, and then you just connect. Up here, I can select the database. And in here, I can enter cipher statements just as normal. And this is what you will see when you get the result of such a query. You can zoom in and out just as you would expect. And the first thing that's different to quite a lot of other tools is that we decided to use, not to use circles, but to use little squares to represent nodes, because we can put more text into them. You can hover over the nodes or relations and get more information, and you get the data within those nodes displayed here. You can also click on the nodes and see the data in a bit more detailed way. For example, you see the relations at the bottoms that are relevant to this node. And you can not only inspect the node, but you can edit the node. And this is a really important requirement for us, that you could edit all the data, and we needed it for the other things as well that you're going to see in a minute or two. So far, so good. What we would now normally do is arrange the nodes so that they somewhat resemble the little island that I've just shown you. However, after doing that for about 10 years, we got quite tired. So is there a better way to do that? Yes. And what we have is perspectives. Perspectives are persisted arrangements of nodes, and you can have many of them. You can store them in the database, and other users can see them. And if you now look at that arrangement and compare it to the island, it becomes quite clear what the data shows. Here is where the train goes around in circles. Here are little pieces of train track called way. We have our switches, we have our signals. Here you have the situation in front of the train station. And we are quite happy and really use that in everyday's life. What you can also do, which I'm not going to show, you can have pre-computed layouts. That means we can arrange nodes based on their properties. We use that a lot to actually do error correction within the data and show where possible problems lie. But that would be stuff for another talk. What I'd also like to show you is if we look at a switch here, I'm going to change the styling. And you see that in here with the switch, oops, a switch has 3 ends. This is where you basically come from, and then you can decide to go straight on. That's the trunk of a switch, or you can take a turn, which is the branch. And you have it the other way around as well. The start, the trunk, and the branch. This is where you take the turns. We will need that later on, but you see that we also support styles. Also, as a side note, the styling here, the colors of the nodes are created randomly, and we have Python in our style file, so you can do complete dynamic layout changes depending on basically whatever you want. Okay, so far we have our editor. Let me also show you quickly that, of course, we can add nodes and connect nodes, add relations as we want. But we don't need them right now, so I'll delete them again. Now, if we go on a switch, or let's say a signal here, you find the data. And now you might ask, what is all this gibberish? I mean, it's nice that we read forward and semaphore here, but what does it actually mean? There's a property railway signal main form. And this property comes from the OpenStreetMap world. What we can do in our system, we can hover on things and find a description. We find that, for example, the semaphore indicates the shape of the signal, which might be mechanical or light. And we have descriptions for everything here. You might ask yourself, what's a signal? Up here, you find the description. And within the description, you might find other properties that you're interested in. What is this description thing? You find a description, and so on and so on. Everything is described in our system, or can have a description. The same works also if you look at the details of a node. Now, what's the secret sauce here? The secret sauce is that we have a metamodel. We didn't use RDF, we have our own. And I use another perspective, here's the first bug, to show you what I mean by that. We have developed our own little language to describe labels. For example, here we have a meta label for the signal. This describes the signal. This is the text that you will see when you hover over signal. Up here, you have the description of the form. It indicates the shape of the signal, mechanical light. We've seen that before. And this property is connected to the label, and that connection means it's part of that label, or it's strongly recommended for that label. Even though we have a schema, we don't enforce the schema, we just highly recommend things. And so if we have properties and we have labels, of course, we also can describe relations. And we have a little more advanced thing. This is called restriction. A restriction basically describes what nodes can be linked to other nodes using what kind of relations. So this is an example of our own little language. And the implementation we have here for our Nummerland, the little island with the 2 mountains. And we can, just with every node, we can change things. We can edit it. For example, I changed the description here. And if I now go back to the actual instance data, and I can just hover. you find, that the description has changed. Everything here reflects what we have in our metamodel. It also has having that metamodel in the background means that, for example, if you look at that list of properties here, you wonder, are they all relevant? And I can activate the signal and now label, and you see now that those properties, only those properties, belong to the signal. And you'll have the same effect, or you also have results, for example, if I delete this property, that actually was right to do. I saved that. If I now look at the signal again, you see that we have an exclamation mark here. It means that the signal label is unhappy. If we edit the object again, you see that up here, it's now recommended that we fill out that property, and I save it. And now the next time you open the signal, everything's happy again. So what you see is that we not only have the semantic support when viewing things, but that we also have semantic support when editing things. And I'm really, really happy, I have to tell you, that our team has brought this editor to life, because we use it every day, and I'm quite excited about it. We have other nice features as well. For example, we have a full text search. Let's look for the semaphore that I mentioned before. You see that we have some nodes that can be found using this full text search. Can we only use a graph? No, we can also show a result table, and you can have this result table for all queries. And within the result table, you might have nodes as a result type. I think if you work long enough with Neo4j, you know what I'm getting at. And we can hover over it, and we get a meaningful preview of the node. We can click the node and inspect it again. When we look at the result, we can also filter things. For example, this might be something which is good for me, but I really only wanted to ever see signals. I love signals. So let's filter for signals, and that's all I get to see. Now, there is another way that we have to find objects, and this is something that we developed for end users, but which actually turned out incredibly useful for our power users and developers as well. These are predefined queries which you can parameterize, and because I can't pronounce the word, it's called para queries. This gives you a little form. For example, you can say, I want to have all the nodes of a certain type, let's say a signal, and you get the same results, I hope. Or you could say, I want to have, let's say, just the switches in my system. And we have other queries that are more complicated. Now that itself is useful for the end users. The nice thing that it can be very easily extended. I have another perspective that shows you how. Those queries are again just nodes and relations within our graph. Remember the query up here? I want all nodes of type well, here's the query. I want all nodes of type label, which will result in a cipher query, and label is defined over here. This is the query that we use to actually generate that selection. So everything in here is highly dynamic in a way. You can create your own forms, your own queries for end users using that system, and everything is a node. So all power to the graph. Now, let's do a little challenge here. Let's say in here we have multiple signals. I think you've heard that I love our signals. And what I want is only the signals that are at exit points of switches. So not where you enter something, but where you leave the switch. If we look at the data, I'm interested in signals that are at the end, at the orange or red ends of a switch. And how could I possibly do that? Of course, I could just write a query in Cypher as we used to, or I could use something else. I look for switches because we said, well, it should be at the end of a switch. And those are the three switches. Now I can go to the right side. And we have a set of switches here, and then can decide which relations I want to follow. And we have seen the trunk is where you go straight on. The branch is where you take a turn. So let's follow those connections. And we come, let's have them automatically put in an automatic layout. Let's rather use another one here. Those are the endpoints that we see. But what we wanted to have are the switches standing next to those waypoints. So I follow the next two relation coming in. And those are the 5 objects. Let's arrange them again. That's not quite nice, so I do it manually. This is the results that I now get. We went from 3 switches following 2 different relation types. We came to our 5 waypoints, and we ended with this selection of items. As I said, I'm interested in signals, so we just filter for those. And the task is complete. And that way, end users can navigate small or large data sets as they please, without ever having to type in a single word of Cypher. I think I leave it here for now, and rather tell you what's going to come. We have to do lots of bug fixing, and of course we're going to work on the user experience as well. There are other features that we want to have. The semantic support also when we do relationship adding. We want to improve the property adding, have syntax highlighting for the Cypher files. We want to edit our styling files within the browser. And we want to have custom start pages if you have your own wishes or your own landing page within the system. You will find the graph editor, or you can find it right now, on GitHub. This is the URL to remember. We only update that repository from time to time because we do in-house development, so we copy things over, but we still love your feedback. Do send us merge requests or mail us with criticism, with ideas, with general feedback. Send us an email to teamiga@deutschebahn.com, and we're really happy to hear from you. Thank you. So now the question is, do we have questions? Mhm. Okay, John asks if it performs well on a graph of the entire network. The graph editor basically works on graph databases of any size. Of course, I wouldn't recommend to display 2 million nodes at the same time. It's really hard to display many nodes. We use Sigma.js, which in turn uses WebGL. So we can display 5,000 or 10,000 nodes. For other things, you have to do smart queries so that you only ever see a subsection. But generally speaking, the editor works on any graph database which supports LPG. And we've also tested the editor, for example, on the demo databases that Neo4j provides. And I can't really see the other questions. Okay. I think I don't see any more questions. I could then really use the time to show you a nice little bonus feature or just an application of things. Let's quickly head over to our dataset. Let's imagine this is a toy train, and we want to sell things. What we could do is we decide, well, we want to just put those items here up for sale. I've selected those and I can add a new label. I've prepared something for sale, something that can be sold. Yep, we want to put that up for sale. We apply that, and what you will find is that the color has changed. I told you before that we have automatic color selection depending basically on the labels that you've assigned to the nodes. Now, let's also put that label up here. And because we have put up this new label, and you see that the label is not happy right now, when we edit it, we now get a new recommended property. That's the price. So I'm going to sell that for €2. And the reason that works, as you can imagine, is because we have a metamodel for that in the background. We've defined a label with a price connected to it, and that's the reason why I can enter the price here. So that's it for now. I hope that you can download the editor and that you find it useful. Enjoy the rest of the Notes conference, and we are really looking forward to hear from you. Thank you. I hear that there are new questions, but now the session is complete. Okay, I think if you still hear it, please contact me directly, and I'm very happy to answer your questions, or members of our team are going to help you with that.